Good morning. Thank you all so much for having me. I appreciate that. As Delbo mentioned, I do work for the Project Lead the Way company, and we do provide STEM programming options for biomedical science, computer science, and engineering from pre-kindergarten to 12th grade. We have a partnership with Verizon, the phone company Verizon, and as a part of this partnership, we have created some free STEM activities, and that's some of the information that I'm going to share with you today. And so I'm going to go ahead and attempt to share my screen, and then I'm going to ask you if you can see it, and then we'll get started.
Yes, we can see it.
Okay, thank you for letting me know that. I am going to ask Karen to do me a favor. If you would you mind, well, I don't know if you can or not. If you can accomplish this, you might have to like set up an account to do it. And this is just a backup plan, but I'm a little bit worried about my computer sound if I unplug these headphones to show my video. So if you could navigate to this website, Karen, and see if you can create an account. I'll just use you as a backup plan to show a video, and hopefully none of that will be necessary. And don't worry about it. If you can't get there, we'll make something work.
All right, I'll get started on that for you.
Okay, thank you so much. Sorry, I just thought about the having to set up the account part, and I don't know how complicated that is. But speaking of that, if you as a teacher decide that you want to use any of these activities, you do have to create an account. And my understanding is that it isn't very complicated, and it is certainly a free account. So there's, no payment or anything like that. But once you have the account, what I'm going to do here is just navigate to the home page so that you can see kind of what that looks like. And I want to scroll down because I think this is a really interesting set of statistics. We have done a lot of partnerships with schools, and what we have found is that students that go through these particular activities, and I would go ahead and go out on a limb and say, similar activities, so I wouldn't say they would have to be exactly these, but the data is on these activities, that the students end up being 53% more engaged in school. They end up doing 3 times better in math and 2 times better in reading. And I believe the reason for that is these activities are activity-based, project-based, and problem-based. And so as a result, students, they're not just being fed information and then giving you that information back in a worksheet or even verbally. They are actually having to use critical thinking skills in order to complete these activities. They are having to be creative and solve problems. And I'm a big advocate of giving students as many opportunities as possible to solve problems. And so I just wanted to point that out. I really think these activities are good, but we have lots of activities through Project Lead the Way that are outstanding, and there are lots of vendors out there that have good activities. So I would challenge you to be on the lookout for some good activities. And so I'm going to go ahead and click on View Activities and just give you a little bit of an overview. So there are 8 different activities that you'll have access to. And as far as those 8 activities go, some of the activities do have some supplies that you would have to purchase, and they're relatively inexpensive, but if you were trying to buy a whole classroom set, that might add up a little bit. I don't know what the OEIP grants, what that looks like. If you can spend that money on things like this has nothing to do with Project Lead the Way. These are things that you would buy from Amazon. So if you can use that grant money to purchase some of these, that might be a good thing that you could write for, because these activities have teacher guides and student guides, which I will show you. All of these activities also vary in length. And it's my opinion, I believe the shortest one says 60 minutes, and I think the longest one's just 120 minutes. But I would probably say that I could see these being stretched into a lot more minutes if you wanted to do that. I think that they have tried to cut it into like a 2-hour time frame so that if you ever want to use these activities for, you know, like a summer STEM camp or a Saturday camp or something like that, you know, you can fit it into the time that you have. But in the actual classroom, if I were doing this, I think, you know, if it would work out, I would probably do multiple days of 30 minutes at a time. And I, again, I think you could spend a lot more than just 60 minutes. So the very first one there that says wearables, you can probably see that. That one is one where the students actually program a digital name tag. And so there is an expense for that one. It's $11.69 to purchase that name tag. And they give you information. I said Amazon. I think you can get it from Amazon, but they give you information within the activity as to where you can purchase if you're interested. But my thought on that, particularly in an elementary classroom, is that, you know, you could probably get by with buying 2 or 3 of those and maybe have the students, everybody does the activity, everybody does the programming, but maybe the student just gets to download it to the actual little name tag, and maybe they get to wear it when they're student of the day. I know in the younger elementary, you know, they're the line leader or whatever, but in the upper classes, you know, whatever that student of the day, what their responsibilities are, it'd be pretty cool for them to get to wear a digital name tag that they created as a part of the privilege and honor of being that student of the day. And then the next one that we'll look at is the virtual reality. And on that one, you do have to purchase a Google Cardboard. Actually, it doesn't have to be a Google, but a cardboard that's compatible with the Google Cardboard. And those run anywhere from $6 to $15 on the low end. And then you can spend a lot of money on those if you want to, and purchase one that's not made out of cardboard that, you know, would probably be more durable for the classroom setting. But I've used these with students, and I do believe that, you know, they like it so much that they will take care of the cardboard. And so the little $6 option definitely would, you know, serve its purpose. And again, on those, I would say if you're working in groups of 3 or 4 students, then you could probably purchase one per group, or maybe one for every, for 2 groups to share, depending on how you decided to do the activity. The good news on the rest of these is that there's no other supplies that are needed that have any kind of cost assigned to those. And so the 3D design and printing, you know, I spoke too soon. On this one, if you have a 3D printer, that would make the activity really the ultimate activity. Their suggestion is that there are definitely places within our communities that have 3D printers. And so their suggestion is if the school doesn't have a 3D printer, that perhaps you could go to the library and print, or to, you know, maybe a business or industry in your area and do the printing. I don't find that to be very feasible. You know, you might be able to work it out, but I would say on that one, you would need the 3D printer. And now the rest of them, from augmented reality down to digital photography, music mixing, emoji design, and coding and game design, there are no special supplies. Now, all of these activities do require some kind of computer. A laptop works for all of them. Chromebooks work for some of them. And so, you know, those kinds of things, you just have to dig in and kind of play it by ear as to what kind of computer you need. But I believe it does tell you in there what you would need. And so I'm going to go ahead, and the one we're going to look at in a little more detail is the emoji design activity. So let me click on that. And I just wanted to show you that when you click in, these are the activity materials. So these 5 materials are the activity materials that you as a teacher would use, and you as a teacher might give some of these things to your students. And so there's also the video. And Karen, how are we coming on the video, on getting logged in?
I registered, and I'm still waiting for an email, and the email said it could take up to 48 hours.
Oh, okay. Thank you. I registered so long ago, I forgot about that part. So we will hope for the best on this, but would someone please interrupt? If you cannot hear the video, please let me, so that we'll go to a different plan.
Welcome to Verizon Innovative Learning. Wow, this is really exciting news. I can't wait to share it with Lily. But this text just doesn't show how excited I really am. Oh, I know. I'll add an emoji.
Hey, future innovators. I just got some really exciting news that I wanted to share with a friend, but words just weren't enough. So instead, I decided to use an emoji. And actually, that's today's Verizon Innovative Learning Lab, how to create an emoji. Emojis are all around us, from text messages to emails, on all forms of social media. We can use emojis to express ourselves. Emojis originated in Japan in the late 1990s. When translated, it means pictograph. When broken down, the word emoji is the Japanese e, meaning picture, plus moji, meaning character. These picture characters have been part of our e-communication ever since. Have you ever wondered how your favorite emojis or even animated characters come to life? Well, it starts with a great idea and a very talented graphic designer. Let's go meet him. For today's lab, you're going to use a graphic design software called Vector to design an emoji that represents an emotion of your choosing. To design your emoji, you'll become a graphic designer. Graphic designers are people who specialize in visual communication. They design, animate, and bring ideas to life. Their work can be seen all across all types of media, from digital to print. Let's meet an actual graphic designer who brings all of these ideas to life. Today, we're talking with Kuhn Tran. So Kuhn, thank you so much for giving us some insight on this exciting STEM-related job. What is your official job title?
It's graphic designer.
Okay, easy enough. So can you share some of your responsibilities?
I'm in charge of all media assets, and that could include PDFs, emails, Word docs, business cards, website design. So it entails a lot of things.
So what would you say is the most enjoyable part of your job?
I would say the creative process, being able to take a small idea and watch it grow and grow into a tangible object. It's rewarding, and seeing the reactions of my clients.
Could you go through the typical process a student might expect to follow while they're trying to become a graphic designer?
Obviously, taking art classes in high school, pursuing a art degree, graphic design degree, but you can also do like little things while you're going to school, like making up projects for yourself, you know, make up a make-believe company and design a logo for them, and then design a marketing campaign for them, you know, and then put that in your portfolio.
What advice would you give today's youth who are trying to embark on the graphic design journey?
Graphic design is everywhere. We live in the world of graphic design. When you go into a grocery store, all the products on the shelves, that's graphic design. When you look on the news, the graphics that pop up when the breaking story hits, that's graphic design. You go to the restaurant and you look at a menu, that's also graphic design. So you can draw inspiration from anywhere. Networking is also an important piece as well. Meeting people in the industry, you never know what type of opportunities can come up.
So how do you feel that the Verizon Innovative Learning Labs, such as the emoji design, can help students get started?
It'll definitely give them a foundation into what it's like to be a graphic designer. I mean, I could draw a circle, you could draw a circle, 2 dots and a U, and you've got a smiley face. It's nice because it exposes them to the possibilities and the responsibilities as a graphic designer, and let them know if that's an opportunity they want to pursue.
Before you go, we would love to see your graphic design skills. Can you please show us how you designed your emoji using Vector?
Sure. So first thing we have to do is explore some of the tools that we have available. The Eclipse tool will be good for creating an emoji. Then what we need to do is think about the colors that a happy emoji will make you feel. So I'm thinking yellow. Then we need to make some eyeballs. So the Eclipse tool is a good tool for that. Then pick a darker color for a higher contrast. Just to make it easy on myself, I'm gonna do Control-C, Control-V for copy and paste. So now I can just move it over, and now we got 2 eyeballs.
Boom.
Then we're gonna copy and paste it again, and make a mouth. And look, he's like saying, oh no!
Yeah.
Now we need to grab the rectangle tool and draw over the mouse symbol. Select both of these, and then select the subtract option here. And that's gonna remove
I see. So now it's in the shape of a mouth.
Yeah, exactly.
Okay.
Make it a little bit bigger here. And now we have a smiley face.
All right.
However, I want to explore my options, so I'm just going to copy and paste it over, and we're gonna draw a different mouth. So I'm gonna use the pen tool this time instead of the Eclipse, and I'm just gonna click, click, click and drag, and then click. So now we have 2 mouths here. Which one do you like best?
I actually like the one on the right.
Why is that?
To me, it has a wider smile, a more happy, like, grin.
I agree, yeah. And that's how you create an emoji.
Awesome.
Using vector.
This was a great example of how to use the design process. Good job.
Thanks.
And also, I want to thank you for being part of the Verizon Innovative Learning Lab. That was pretty cool. And now it's your turn. Pick an emotion and design your own emoji. And remember, as always, have fun. Welcome to Verizon Innovative Learning.
All right, just for a moment, I had to stop that share because as you could see, the video wanted to play twice. So let me see what we can do about that. Oh no, not good. Okay, can you see it and can you hear me again?
Yes, we can, Sarah.
Okay, thank you. I appreciate you guys. I can't tell what you can see, so this is great. So now I want to go ahead and actually open up the teacher guide and show you some of the information that's given to you as a teacher. But one thing I wanted to point out about the video, I really love, and all 8 of these activities do this, they tie a career into the activity. And so this opens up an opportunity for you as a teacher to talk about a career with your students that maybe they haven't thought of before, depending on their age group. And so one thing I wanted to really point out that I like about this is that you'll notice that he was a graphic designer. So he wasn't an engineer. He wasn't a computer science engineer or anything like that. Things that we think about, being in the STEM area particularly. He mentioned that a good thing to do would be to get an art degree, not an engineering degree. But what I think you will see is, as we look at this activity, and certainly if you do it with your students actually use a lot of STEM and engineering design processes in order to problem solve and think critically about this particular problem and come up with a creative solution. And so I just wanted to point that out. I love that there's STEM in a lot of the different careers, and sometimes, I don't recognize that sometimes. And so just wanted to mention that. And so then on the teacher's guide, and I hope that's large enough that you can actually see kind of the words and stuff. Let's see here, maybe I can make it a little bit bigger. Each one of these, again, is very similar. It gives you an overview, so just kind of a paragraph to let you know what the students will be doing. It tells you right off the bat what equipment you need. So in this case, you need a laptop. And what I believe to be true about this, if it says laptop, then it doesn't mean Chromebook, just as an FYI. The vector graphic design software is a free download, and I think that's why the Chromebook won't work, because it is actually a download, not an app. And you know, this activity is a couple of years old, and I didn't Google to see if vector graphic design has an app. They may by now, so you might check that if you are a Chromebook school. It tells you exactly what resources you'll be using, the intro video. There are some key terms that I'll show you here in a minute. There's a vector reference chart that shows all of the different, you know, like the ellipse. I don't know if you could see that well enough on the video, but he used the ellipse to make a circle. And so it doesn't go over all of the different options. It goes over the ones that the students would likely need to use, and they can certainly explore. And then there's a tutorial page so that you and they can become more familiar. I want to encourage you as a teacher, you do not have to be a vector video expert to be able to do this assignment. And I know sometimes as teachers, we like to have, you know, lots of background information, and there's certainly nothing wrong with doing our homework and getting that background information, but we don't have to be the experts in the room. The students are really, you know, with today's learning and the way it works, they're really okay with that. Now, they may be a little frustrated at first when you know, they ask a question and you don't just give them the answer, you tell them that they're going to have to go and figure it out. But it gives you a great opportunity to ask a lot of open-ended questions. One of my favorite questions to ask when I'm doing a project like this is, okay, where did you get stuck? Or, okay, what do you need to know? All right, what do you know? And help the students walk through and work through what they know and what they don't know, and so on. And so, and let's see here. There are standards, and I'll just gloss over these quickly. These are next gen science standards, and they're all around the engineering design process. And then the learning goals, this is something I'll just pause there so that you can read those just real quickly. And then it says the session length there is 60 minutes. It gives you preparation. And then finally, we get down to the learning session. And so once you see the words learning session, this is where you would actually start, you know, with the students. So number one is watching the emoji design introductory video, which we already did. It gives you some questions that you can ask to engage the students after you've shown the video, field a few responses, and then it says introduce the engineering design process. And I would imagine that most of you are familiar with the engineering design process. You may be more familiar with it from the scientific investigation, that process. It's very similar to the engineering design process. And you're going to see this picture in the student guide that will open here. But I'm going to go ahead and show you, this is a little bit better quality picture. The engineering design process is circular. And so although we typically start with asking a question, you can actually go either direction, and you should actually go around the circle multiple times. And so once you have established what the question is, you're going to explore different solutions, different ideas. That would be kind of like a brainstorming scenario. And then in this particular case, you're going to build a model. You'll build your emoji design. And we have, and you'll see this in a minute, but there will be some constraints that we want to make sure that we're reaching. And so you'll evaluate against those constraints. And if you haven't, you know, covered all the constraints, you may go back to building and rebuilding, and you may even go back, you know, another step to exploring some more. But the really big point that I want to make here is that we have to give students time to go through this circle at least a couple of times. Anytime we're doing any kind of engineering, engineers never get it right on the first go. And I think most engineers would tell you it's more like 100 iterations before they really get it to a marketable product. And so I just want, we need to teach our students that, number one, it's okay not to know everything. Number two, it's okay to build a model and fail And that's a hard thing for a lot of students to experience. But my opinion is we're doing them a disservice if we don't allow them the opportunity to fail, but fail forward. And so by failing forward, what I mean by that is, yes, we failed at this particular model, but then we have the opportunity to go back and make it better and cause it to work. And so I'm really excited about giving students that opportunity. And so at this point, back to the teacher's guide, it says we're ready to hand out the student guide. And so I don't think I have opened that yet. So show you where the student guide lives. And so now this would be an option that you might want to consider. So first of all, we have the overview, and there, as promised, there's the engineering design process. So students could be looking at that while you're explaining that. But my thought would be the procedure has 3 parts. Part 1, part 2, part 3. And because this is in kind of a worksheet format, students are frequently, give them a worksheet, and what do they want to do? They want to get through it as fast as they can. And so I might suggest that you only hand out part 1, which that works out well because it's all on page 1. Part 2 and part 3 actually are shared on a page. So you might want to, Xerox that in a way so that they're only seeing part 2, or cut the bottom part off, or however you want to handle that. And so go ahead here. Let me get back to the teacher's guide. And so I wanted to point out that part 1 is the activity component of the Apb approach. And the Apb approach, I actually had a small video that I was going to show you about that, and I had computer issues this morning. That video is on a computer that will not boot this morning, so I'll just kind of talk you through that. But the Apb approach, the A stands for activity, and then the P stands for project, and the B, this is kind of a weird thing that Project Lead the Way did. So in the word problem, there's a B right in the middle, and that B is for that B in the word problem. And so in the activity approach and in the Project Lead the Way curriculum, if you're familiar with that, we always do 3 activities in our elementary lessons and in most of our middle school lessons. And the activities are the place where students practice concepts, they learn knowledge and skills. And so one thing, in this particular activity, they may be learning, about how to think through the emoji and the emotion behind it, and what emojis are, and that kind of thing. You could possibly use as an activity, it's not the way this particular lesson does it, but this activity, you could probably do an activity where they're actually learning the software a little bit before you jump into the project and so on. But the point is that the activities are very focused. They're not open-ended. Every student's doing the same thing. They're all learning. They might be working in a group. There's no issue with that, but they're all learning kind of the same stuff. As we move through the Apb approach, the P stands for project. And so that would be a project that's pretty carefully put together so that the activities that you just did and the knowledge and the skills that your students just learned would have an opportunity to surface as a part of the solution to the project. Now, it's totally fine if a student solves the project without using every single one of the knowledge and skills that you just taught them. It's open-ended, so that's all right. But a lot of students are going to use, the knowledge and skills that they have just learned. And then the problem, which is how we would end our lessons, is very open-ended. And so the problem is something where, even though, when students in our curriculum, we have students work in groups or at least in pairs for everything, but the different groups may get very different answers. And that is absolutely okay because it's a very open-ended problem. And so just wanted to kind of give you an overview of what the Apb approach is and what that looks like. And so going back here, so we've talked about that part 1 is the activity, and you can see it's labeled activity, so that's all good. Part 2 is labeled as the project, and this is where they're going to be doing the explore part of the engineering design process. And so it takes you through the steps of opening Vector on the laptop, practice creating with each tool, and we have a Vector reference chart so they know exactly which tools you want them to practice with and get familiar with. And then it says once you feel familiar with the tools in Vector, select new file and start with a blank project box, and then they give them a little small thing to create. They give them criteria, what they want it to do. They give you constraints, and primarily on this, the constraint is time. And so this is definitely an area, if you have the time in class and you wanted to give them more than 10 minutes, I think that the students wouldn't mind just playing around in that software for a good 30-minute, period, if in fact you have time to do that. And then part 3 is the problem part of the APB model. And so in this, we're actually going to be building the model, evaluating it against the constraints, explaining what we did, and hopefully going back and revamping the model, making it better. And it actually even leads them through a little bit of that. But they have a matrix, a decision matrix, where they're answering some yes/no questions, and it tells them right there in their worksheet, if they answer no to any of the questions, then they want you to cycle back to the model. And this is designed so that they will hopefully answer no to a question, because again, the whole point of the engineering design process is it's a complete process that takes more than one time through the circle. Let's see here.
Sarah?
Yes.
It's a few steps back, but in the chat, Courtney Norton, she asked, how would you recommend sharing the video with students?
So if I'm understanding the question correctly, if you are in the classroom setting, I would just probably share that, via the smart board or something like that, if that's a possibility. Or if the students have headphones and you want them to, watch the video on the laptop, they could do that. The video is such that you can download it and, play it without internet if that's an issue. I'm not sure if I understood the question. Did that answer that question?
Courtney, if that did not answer your question, you can put in the chat, expand a little bit, and we'll ask her more. So.
Please do. I do want to answer your question. I'm just not sure if I understood exactly what the question was.
Okay. So
while we're waiting on, go ahead.
Oh, I just said thank you, Sarah.
Oh, thank you.
Is there another one? Denise Payton asked, what if still in remote learning?
So if we are still in distance learning or remote learning, I would think that with some thoughtful design, I think that you could probably do this. I would probably recommend that you still have the students work in pairs. And so if they could use, whatever your school uses, if they could use maybe Google Meet or some kind of, even FaceTime. Students really probably don't need us to tell them how to connect digitally with their friends. But I would still probably put them into a group. And, maybe just a group of 2, just to make it a little bit less burdensome with the technology aspect of it. But I think you could do that. I think you could absolutely, share different parts of the lesson, maybe in a big Zoom call or a big Google Meet call with your whole class, and then divide them up into, their group time or whatever, and have them work through. But, as far as the video, I would, they would have to have internet capability to do any of this, because they would have to log in, I guess, to see the video. And maybe that just answered the question that was asked previously about the video. I guess really probably only the teacher would have access to that video, as far as, the account login and stuff, because your students aren't really ever going to log into this. You're just sharing the information with them. Okay. So now that I think that through, that might answer that question better.
She expanded a little. She said, just wasn't sure if students should have an account or something, or just share as a teacher.
Yes, so I don't think there is a way for the students to have an account as far as I know, and so it would absolutely be share as a teacher. Now, if we are on distance learning and if for some reason you couldn't share it, you know, via a Zoom call or something like that, which I mean, we've just demonstrated that that should be possible, but if you couldn't, like I said, you can download it, and I believe that you could probably then upload it back into maybe Google Drive or something like that. It's probably too large. I haven't tried it, but usually videos are too large to email to your students, but you could probably email them a link and show it hopefully that way if you had to. But I think just showing it, my preference would be show it and then have that classroom discussion around it. And so that would make the best sense to me.
Okay, well, thank you for the questions, ladies. Back to you.
Yes, thank you so much. And keep them coming. If anybody else has a question, just let me know. I can't see if someone is like raising their hand or something. So if our career tech friends will help me with that, please interrupt me at any time. We're really getting close to wrap up here. And so I just wanted to show you the key terms and that kind of thing. So it does start off on the key terms. It talks about the Apb approach. So, and there's a nice little graphic there. I don't think I can blow it up, but I think it will help you, you know, just remember what we talked about on the Apb approach. And do you share that with your students? You can if you want to. It's totally fine for them to understand what they're doing, not necessary particularly. And then this is the part that tells you very specifically which tools they should investigate when they're having that explore time using the software. And then there is a check for understanding, and this is something, you know, use this if you want to or not. But if you want to do a check for understanding, I think this is a pretty good way to do this. And this is something you could have students do either on their own or in a group, whatever your class, you know, looks like, whatever you want to do with that. But I like the questions. They're a little bit open-ended, so there's not really a right answer, wrong answer necessarily. There are multiple answers that could be considered accurate. And then I don't really think on this one you would need this, but they even have a check your understanding answer key, just in case you would need it. And so that really concludes this particular activity. I'm going to go back and take a look at the other activities, not in any kind of depth at all, but are there any other questions around this activity before we move away from it? Okay, I'm mainly doing this next part just so that you can see kind of the navigation. So I'm going to go ahead and click on the home button again, and then just scrolling down to view activities. And so there again are your 8 activities. And I just wanted to kind of wrap up by saying that Verizon Innovative Learning provides this free technology and hands-on learning experiences to help give students the education that they deserve. In partnering with Project Lead the Way, we're giving kids the ability to do more in this world. This online portal will provide teachers like you access to fun, free, and interactive STEM activities, exposing kids to new skills like virtual reality, augmented reality, 3D design, and more. And again, each one of these 8 activities has a career, and it's always highlighted in the video. So really the format that I showed you on the emoji design activity is just almost, you know, verbatim as far as the format of it. Of course, the activities are different. So that is really the conclusion of this presentation. And I am definitely very happy to attempt to answer questions.